Here we have question number 4 from homework number 12, and the question is stating 2x squared y double prime minus 3x y prime minus 3y is equal to 0, with the condition that x cannot equal to 0. To solve for this problem, we have to split it into two parts and say that x is greater than 0 and x is less than 0, which we will solve for later. Now, to solve for x greater than 0, we're going to use the Cauchy-Euler method. And to do that, we can see that we just bring down the 2, and our x squared plus y prime is going to turn into d times d minus 1 minus the 3 comes down, the x y prime is going to turn into d minus 3. The y does not turn into anything, it just goes away, and the whole thing is equal to 0. Now, we are going to multiply it out and simplify it. We will get 2d squared minus 2d minus 3d minus 3 is equal to 0. Simplifying it further, we're going to find that we get 2d squared minus 5d minus 3 is equal to 0. Now we're going to need to put this into our characteristic equation. Therefore giving us 2m squared minus 5m minus 3 is equal to 0. Simplifying it, factoring it out, simplifying it, we find that it'll be 2m plus 1 times m minus 3 is equal to 0. Therefore, we can state our m is equal to negative 1/2 and positive 3. And therefore, our fundamental solution is going to be equal to e to the negative 1/2 t, not x, not y, but t, and it will be e to the 3t. And therefore, we can state that our general solution is going to be y of t, not x, but t, is equal to c1 e to the negative 1/2 t and plus c2 e to the 3t. Now, earlier we have to state that our x is going to be equal to e to the t, and therefore our t is going to be equal to natural log of x. Now we take this and we're going to plug our natural log of x back into our general solution. In doing that, we will find out that our y of x is going to be c1 e to the negative 1/2 natural log of x plus c2 e to the 3 times natural log of x. Now, due to natural log functions and everything, the e and the natural logs will cancel out, and as well as the natural log rule, the 1/2 is going to turn into the power. So therefore, our y of x is equal to c1 x to the negative 1/2 power plus c2 x to the 3rd. And that is our general solution for when x is greater than 0. Now, for when x is less than 0, we are going to say that our x tilde is equal to negative x. And by saying that x tilde is equal to negative x, we are also stating that our dy over dx is equal to negative dy over dx. Or excuse me, dy over dt. And we are also stating that d squared y over dx squared is equal to d squared y over dt squared. Notice that for the second derivative, it does not become negative, but the first derivative, it does. Keep that in mind. So we're going to take these and plug it back into our original equation, giving us 2 times negative x tilde squared d squared y over dx tilde squared minus 3 times negative x tilde times negative dy over dx tilde minus 3y is equal to 0. So now we are going to simplify it out, get rid of some negatives and everything, and because we can say that this negative and this negative are going to cancel out, therefore the negative 3 stays, and we can also say that this negative is going to cancel out because it's squared. So in doing that, we're going to find out that 2 times x tilde squared d squared y over dx tilde squared minus 3 x tilde dy over dx tilde minus 3y is equal to 0. Now, in factoring it out and using the characteristic equation, we will find that the general solution for this is actually going to be the same thing as we had on the previous page. And we can, if we look, we can see that the equation has not changed at all. The only thing that's changed is we've added x tilde into the equation instead of x. Let's get a different color to show it. So you can see instead of x, it's an x tilde. That's the only thing that's changed. We still have a negative there, and this is still positive. But the only thing that has changed is the x tilde. So therefore we can state that our general solution is actually going to become the same thing, which is y is equal to c1 x tilde to the negative 1/2 power plus c2 times x tilde to the third when x is greater than 0. When x tilde is greater than 0. Now we need to plug our negative x back in for x tilde. Therefore, we are stating that when x is less than 0, our general solution is going to be y is equal to c1 negative x to the negative 1/2 power plus c2 times x to the third, and that is your general solution for when x is less than 0. And that completes the entirety of this problem.